All right, we can get started and hopefully other people will join in as we go. That's what happened Tuesday as well. So hello, everybody. It's great to see you. I want to welcome our lecturer today, Benjamin Daniels. He is a research fellow at the McCourt School of Public Policy at Georgetown University. He also works at Dime Analytics to improve the reproducibility, transparency, and credibility of development research. I could go on and on about his research and accomplishments, but I'm just going to pass it over to you, Benjamin, and have you take it from here.
Great. Thank you so much, Amy. Welcome, everybody, and thank you for joining today. As Amy said, I've been working in research for about 10 years between the World Bank and Georgetown University. My research focus is in public health in low and middle income countries and resource constrained settings. And I also work extensively on improving research technology, reproducibility, credibility, and so on. If you haven't received my bio already, we have just released a book on the topic and it's free online, so you should look it up and read it. I think it's very good, but that's just because I spent a long time writing it. And I hope it is useful to everyone who reads it. So I see a couple of people online today, so welcome again. In case you haven't seen me speak before, you'll know that I tend to speak a lot and I tend to speak quickly. So please stop me. Either say, Ben, slow down, or ask me a question. I love having very interactive presentations. I won't call on anybody today as I do in settings where I know people more personally, but I may ask kind of generally to the audience, what do you think of X? Or, can you share an experience with me? You don't have to answer, but I would love if you did. It's a small groups and I think you know each other, so I should hope that people wouldn't be, too shy in front of their peers. This is a difficult topic. It may or may not be the first exposure for a lot of you to the technology and the concepts that I'm going to talk about today. And I'm going to talk about them using metaphors and mental maps that may be new or unfamiliar. If you don't understand, that's good. That means you're being exposed to something that you don't know. That's really important. So, excuse me. So I want you to stop me and ask questions, and I want you to say, take a minute and re-explain that to me. I'm going to ask you about what you think about things, and I want you to tell me what you think about things. So Git and GitHub, I'm going to start with a question, like I said. Who has any experience in this topic? Just so I know where people are coming into this lecture from. I don't see any hands or eyes, so I'm going to assume that nobody has any experience if that's the case. Yes, go ahead. Abdul Rashid, is that the right name to call you by?
Yes. So I have an account on GitHub, but I won't say I know it. I'm not an expert. I just use it to start some things like I like, some codes or some works. Yeah, that's I think the highest I've been with. Yeah, just getting some repositories and yeah.
Great. So you've seen what GitHub looks like. You've seen that there's code on GitHub and that it's easy to find and that it's backed up somewhere. So you know what GitHub is working like. Has anyone used Git on their desktop as well, through any client, whether it's GitHub desktop or there must be others. I use GitKraken or GitLab or Tower or any of the other clients on their desktop. Has anyone used one of those in their work? No? Great, then you've come to the right place. So let's talk about it. We're going to start with what is Git and what is GitHub. And I want you to know one thing first, actually two things according to my slides. Git is not GitHub and GitHub is not Git. Git is, and I'm going to make you memorize these, Git is a version control software. It organizes versions of every file in your project in an orderly way. GitHub is a development platform. It is built on Git. It uses Git, but it is not Git. It doesn't happen on your computer. It doesn't happen with your files. It happens on the internet. It manages contributions to projects in an orderly way. Now, using them together is great. And the GitHub company, which is now Microsoft, is very invested in making you think that GitHub is Git. but it isn't, so don't be fooled. But it is a useful tool anyway. Together, they let you avoid the problem in the comic here. Am I pointing at the comic, or am I pointing in the wrong direction today? This way? Over there, there's a comic. And everyone who's been involved in academia for any amount of time, which I assume is all of you, has done this. I'm not going to call it a problem because it's just what we do. You naming and renaming and renaming files to tell you or the bald white guy there where you are in your project and what's happening and what this file is for. When you're doing that, you know it doesn't make sense. You feel that this is wrong, but you don't have a better way to do the thing you're trying to do. You're trying to encode information about the file in the file name itself. It is one solution to the problem, to include those three important pieces of information: when it was made, what it is, who made it, ... We call this untidy for our Marie Kondo fans out there. What Git does at the most basic level is it tracks those things for you, the timestamp, we're going to call it, and the initials, or the contributor, or something along that line, for all the edits for all the files, without you having to remember it or modify it manually. So what this means is that in your folder, what we're going to call the working directory, is that Git keeps that working directory tidy. It only has your project there, and it hides all the versioning in the background in a place that you can't see. I'll show you how to see it. You don't want to see it, trust me. But I will show you. That way you're using the same file name over and over, whether it be manuscript.doc, actually it won't track doc files, so manuscript.tech, or something to that effect, without ever changing that file name, so that you're not rebuilding the project with versioning integrated. You are doing that all in the background. Gonna shift tracks here for a second. So Git is what we call a protocol. I'm gonna liken it to email. Raise your, this is a silly one. Raise your hand if you have used email. This is how I tell if the participants are awake or not. I'm seeing a lot fewer hands than I should be seeing at this point. Unless you live in a desert or a cave, you've used email, right? Email is a protocol for sending letters, we call them, online. Now, none of you have ever actually used email, which is where I get you. That's a trick question, actually. You have not logged into email, the protocol, and used it directly. That's insane. I know a couple of people who do. Most of them are 80-year-old professors at Stanford who refuse to trust Google. So I swear one guy goes onto the console and does his emails in plain text. That's insane. Nobody does it. We all use a client or a server relationship for working with email. Now, when you use email, you presumably go onto an app on your phone, or you go to a website, or you go to a desktop client like Mail or Gmail, or I think Thunderbird used to be a thing, or you go to Gmail on your phone, or you go to Proton Mail, or whatever you're using to send and receive emails, right? What you might notice is that if you have an email account, you can get to your emails from any number of different applications, and you can do it at the same time. So that tells you something. Your email doesn't live in the application. It lives somewhere else. And all these applications are using the same protocol to access those emails. Email's awful, and we're not going to talk about why, but it's awful. The security stuff, the standardization stuff, but it works. Your emails are living on a server somewhere on the internet, usually gmail.com, unless you are working in an organization that for some reason prefers Microsoft and Live, which, again, don't ask. So they're living somewhere on the internet where lots of applications can access them. Again, whether that's Outlook or Mail or the Gmail app. And of course, like with Git and GitHub, Gmail is very, very invested in making you think that email and Gmail are the same thing, but they're not. And those clients give you access to the information that is stored on a server somewhere else. They all use the same language, which you do not know, you should not know, and you should never know. And they use user interfaces or UIs to show you the information that is stored in email in a digestible way that you, a human, can understand. We're going to do the same thing with Git. If you go to a lot of introductory Git trainings, they're going to make you fire up your terminal and start typing stuff into a command line that you've never used before. Just like doing email through a command line, I think this is insane. You should not know how this stuff works. You're not a tech developer in your main job, unless you are, in which case raise your hand, and that's okay. You should be presented things in a way that a human can understand and a way that a human can interact with. So we're going to use a client on usually on our computer desktop, on our laptop interface, to interact with a server that holds a lot of this information. That'll usually be github.com, but it could be GitLab. It could be a custom enterprise installation of either of these things if you need that kind of security to keep things away from the public internet. Things you may or may not know, Microsoft also owns GitHub. If you post stuff on GitHub, Microsoft owns it. Just like with Dropbox, because they need to take your copyrights in order to put it on the public internet. They can read all your files, whether it's public or not, because that's what they do. And we can deal with those. So I have lots of security answers and questions, which I'm happy to save and deal with individual cases. GitHub is like Gmail. If it's out there, assume it's going to be on the news. GitHub Desktop or GitKraken, which I personally like, are clients that live on your desktop that will allow you to interact with the server information and to control what's happening on your desktop, just like when you compose an email and then you send it to the server. So we'll talk about what exactly these things do and how they operate, and why, and I'm going to use GitKraken here in these screenshots to show what Git looks like to me. Again, it's a representation of what's happening behind that's made for you. Different clients will represent the same thing in different ways, just like different email clients will show you the same email in different ways, in different contexts and different search features and blah, blah, blah. All that is overlaid on top of the core Git that's happening. So Git. Again, what I'm showing you here is not Git. This is a Git client that is pulling information out of Git to show it to you in a way you can understand. This is GitKraken, which I personally like. Not a sales pitch or endorsement, but I find that it shows things in a way that my small human brain can understand. Git is a software that's running on your computer. It's running in the background invisibly. It's very quick. It's very efficient. That is why people use it, even for large files. I can talk about what types of files later if you like to talk about that. It stores what we call version histories of your files in a way that's really useful. And again, you don't need to understand it. If you want to understand it, great, go get a degree in computer science. I don't even understand it. I just know how to use it. The history of the project is called a repository. So this goes back to Abdul Rashid's comment earlier. He said something which I find very interesting, which I'm going to start messing up immediately. He said he's gone online to github.com and viewed some repositories. That's not correct, unfortunately. You don't go and view repositories. You view files. Repositories, and I'm going to tell you this once, and then I'm going to start abusing the terminology just the same way everyone else does, and as Abdul Rashid correctly did. When we talk about the contents of a repository, we usually mean the files that are sitting there. That is not what the repository is. The repository is the history of the files that are sitting there. So when you open up GitKraken, what it does is it shows you the contents of a repository. It doesn't show you any files. You see any files in there? No, because files aren't what's stored in the repository. It is the history of the files. And a simple one is going to look a lot like this. It has a series of versions, not of files, but of the entire folder. I'm going to start doing that. I'm going to start calling it the repository because everybody does. And the series, each of those versions is called a commit. And together those commits make up the history of the repository. Each commit is a record of the changes that happens between itself and the previous commit. So we're going to start simple. This is a nice linear history with one unbroken chain of past versions. Now you'll notice it does a couple of things for you. And I have outdated screenshots. So if you'll note that a lot of these will say master on the branch name, those have all since been changed to main, since that is the new terminology for all these. That is an outdated terminology, and we don't use that anymore. So anywhere that I have master in these screenshots and I need to update them, see main, and that is what you'll see when you actually go and use this. That's a recent change that's now site-wide, I think worldwide. in Git. So what do we see that Git is doing for us? It's doing exactly the things that we tried to do by putting those initialisms on our files. It's got a little marker there for who made the change. It's got a little marker there for when the change was made. And it's got a little marker there for why the change was made. These aren't great titles, but they give you the idea of what we're doing when we make versions, when we add commits to the repository. Yeah, Amy, go ahead.
Can people be making changes simultaneously, like in a Google document?
Yes and no.
Okay.
That's an excellent question. That's the second part of the presentation. I will address that. The answer is yes, people can make changes simultaneously, but not to the same version. And I'll explain that in more detail. So what Git is doing in its most basic form is tracking those three things that we tried to do with initials.doc. Yeah, Abdul Rashid.
Yeah, so I wanted to know, how does it set the names? Does it do that automatically, or you have to write something and then it will keep updating 1, 2, 3 or something?
Excellent question. I always love when people ask me like what the contents of my next slide is, because that means I'm pacing it well. I will get right to that. Excellent question. Not on the next slide, but in a few slides. So GitHub is a website. It is not Git. Again, it is not Git. It is running on Git. All the features on GitHub are build outs. They are custom stuff that does not exist as part of Git, the underlying software. Unfortunately, well, Microsoft's pretty good these days. It's not the 90s anymore. They're pretty good. I love GitHub. It's a website that you can use to manage collaboration with other people. I don't use it to do Git. That is pointless. Git is happening on your computer, not on the internet, except for one thing, which I'll show you later. What GitHub does really well is it manages and tracks tasks, which we refer to as issues in this world. And then it allows people to submit solutions to those tasks, which we refer to as pull requests, merges, and stuff like that, which I'll also show you later. So when I collaborate with someone like Luisa, who I've worked with for about 5 years on big programming projects like IE Codebook and IE Field Kit and IE Toolkit, she might do something like this: post an issue that says you should put missing codes on all the value labels, and this is what we should do. It's not very specific, but we had a conversation about it, so it's kind of a reminder for me. And then you can see that right there I responded and said I proposed an implementation of this feature in the commit of this name. We're not going to go into the details of what those little codes are at this point, but they're really useful, and they point to, like I said, changes in the code. In this case, changes in the code that address implementing a new feature in our software. What Git and GitHub together will let you do is have a full version of your code available online, having some of the history available online, not all of it, but the parts that are important, and also back up your files, do mundane tasks like providing licensing to your files, copyright notices, the kind of things that you don't think about until you go to put them online and then realize if you don't license your software, it's unlicensed and therefore not usable. It works well. Once you get the hang of it and get into a flow of it with yourself and other people, you'll find that it's not something you can live without. I was telling Amy at the beginning of this presentation before I started lecturing, even if I just do a small task myself these days, I tend to fire up a Git repository, clone it to my computer, and start working there because it saves time, it saves effort, and it saves you from royally messing up your code and data, and then it's already online. So I like it a lot. I use it personally. It takes a couple of, I'm going to be honest, years to get to that point, but the only way to do it is to do it. And so I recommend, trying as soon as possible to do this. So I'm going to walk through basically how we do a small project with, one or a few people, and you grow from there. So to reiterate, the files are not the repository. I'm going to say this once, and then I'm going to start calling it the repository again, like everybody else does. Your Git repositories will manage a lot of files. The repository is not the files. We're going to say the working directory whenever we refer to the folder on our computer where the files sit. I'm going to assume everyone knows how to operate a computer. You'd be shocked at the number of young graduate students these days who have no clue what a folder is or where files actually live. don't know how to type a file path, so I'm going to assume everyone has that skill. If not, go and figure that out real quick. But when you go to your file manager, this is, now I can't remember what it's called. On Mac, if you're using Windows or Linux, it's called something else. But you'll see a file tree, something like this. So if you look at one of, again, I'm going to do this immediately, one of these repositories, it's got files in it. The repository is hidden. It's actually in that folder. As you see, I'm looking at the same folder. There is a hidden folder in there that's called .git. On Mac, that's how hidden folders are created, so starting them with a dot. And it's full of stuff that doesn't make any sense. Don't look there, don't touch it. The client is going to do all of the reading of these files for you. It's written in ultra dense computer language. It is not for humans to read. You can really mess stuff up if you go in there and try and screw around with it. Don't look at it, don't touch it, but that's actually what the repository is. Right living there in that folder is the repository, the history of all the versions of the files that sit in the working directory. Again, that's the last time I'm going to be precise about it. I'm going to now use the vernacular language for most of these things, but this is what's actually going on. And so if you want to ask specific questions, yeah, we can use specific language. We just generally don't because we're lazy humans. So what do? We're going to create a repository and make commits. So this is we're going to come back to the question about naming things. Git creates commits. This is the only, and I mean that's going to have a little star next to it, I'll come back to that. A commit is the only thing that actually sits in the repository. A snapshot of the entire working directory, all the files at the same time. Each commit, and these commits in Gitkraken are represented as these little bubbles, has a name and a timestamp and an author, which are all the things that we wanted when we were trying to version our files manually and kludgily and very obnoxiously to ourselves and everybody around us. Just like renaming a file, you do have to tell Git when to do this. It will not do this automatically, and it will not do things like name them automatically. It will take the timestamp of the author automatically because that's obvious. The other things are not. When to do it and what to call it are human things, and I'll show you why in a second. Actually, that's in the second session, so if I ever come back and I do the collaboration session, you'll learn even more. Doing this by hand is probably the biggest difference from whatever you do now. You probably use Box or Dropbox or whatever your organization has a enterprise subscription to, and it does it automatically. I'll show you in a minute why that is awful, and you will agree with me. So Git is always watching for changes. It will tell you when you have changed something and not say, hey, do you want to make a commit? But it'll say, hey, you can make a commit. Something has changed. This is what has changed. It's very good. It's very smart. It's very fast. But it will only store a record of those changes when you tell it to. And when you tell it to do that, it's called making a commit. You name these. You name them so that they make sense, because Git, while it knows what you are doing in a technical sense, it will tell you down to the letter what you have changed in your files. It has no idea what you're doing. It doesn't know what's on the task list that you keep on your wall or what your boss has emailed you to do that morning. It has no idea. It's not intelligent. It's a machine. You're intelligent. And so we're going to use the machine for the things that machines are good at. And the rest is going to be on our human brains, which understand deadlines, tasks, human languages, and why my tasks that are communicating human language are not done by the deadline. So read this thing that talks about Git versus Dropbox. The presentation will be sent around, and these links should work. These are all short and really intuitive explanations of what's going on. So we name and save our changes. Why is that better than Dropbox or Box or whatever you're using here? Who's used Dropbox? You guys haven't used Dropbox. All right, have you seen this screen if you use Dropbox? If you've seen this screen, your day is over, and you know that. Once you're in here, it's done. You're like, nothing else is getting done today. Now, why is that? And that's because Dropbox stores a snapshot of each file every time you press Command S. And me, I have to go to physical therapy because my hand is stuck in this position with Command S, Command S. I save just compulsively. I have a great joke about Jesus and the devil, about that the punchline is Jesus saves when the power goes out. It's very funny. I'll tell it later if I have time. You save your work often. So Dropbox stores many copies of your files. And it looks like this. Well, look at how often I'm saving it. It doesn't have the exact, it does have the timestamps. 5:30, 5:29, 5:29, 5:28, 4:13, 3:07, 3:02, 2:11, 2 o'clock, 1:59, 1:58. That's how often you save files in reality these days. And every time you do that, Dropbox stores a copy. But when you go back and say, oh, I need that thing I did like about 2 hours ago, do you think it's in the 158 version or the 159 version or the 2 o'clock version or the 2:11 version? Good luck, right? So what we do when we're naming things in GitHub is solving that problem. We're only saving when we want to. We are naming it for the things that we've done or undone. And unlike Dropbox, it stores the entire, again, I'm going to call it the repository, the entire working directory at the same time. So same problem. When you go to Dropbox and you get one of these files back, it is not guaranteed to work with the current state of the other files in the working directory. When you roll back on GitHub, all the files are at the version that they were at the same time. So you know they'll work together. And you can always come back. We'll do that again. That's for the hands-on one, which is the second session, which is a lot of fun, where I actually show you some magic. Right now, I'm going to walk you through how stuff works basically in practice and how to get up and running. So if I was doing this as a hands-on session, I would have you all go to github.com right now and create a repository. It's very easy to do. And I always initialize my repositories on github.com because it does some sensible default stuff that I would rather not do manually on the computer. You give it a name. So one quick thing, that names in Git and GitHub should be lowercase, should use only the 26 American English letters and dashes. So no capital letters, no underscores. Oh, and numbers, of course. No capital letters, no underscores, no accented letters, no apostrophes, special characters, just 26 lowercase letters, 10 Arabic numerals, and dashes. Names for commits should be short sentences in the imperative tense. So in English, that happens to be the same as both the command for a task and what's the tense or mode that it's called in the past? So if you say give XYZ something, that function is both an order and a description of what something does. It works very well. It's very convenient that those tenses are the same in English, which is why we use it for Git commits. Yeah, so when you do it on the internet, you can make it public or private. If anyone has security or privacy questions, please ask either now or later. I'm happy to discuss that because that is really important. You can put licenses and Git ignores on your files, which are really useful. I didn't do it there, but you can do it easily. And then you hit create that repository. So now that's sitting on the internet. It looks like something like this. There's no files in there, but this is what you might have seen if you're going around GitHub, is something that looks like this, except usually with more useful stuff in it. That repository, which is the files and all their histories, is now living on github.com. There is a total copy of those files and their history on Microsoft's servers somewhere in the world, certainly in a place that is not GDPR compliant for anyone who cares about that. Not in Washington, but probably in Virginia, where a lot of these data centers actually sit. But almost certainly not, compliant with most privacy and security stuff. So again, happy to talk about that. We have lots of best practices and guides to what to put on GitHub and what not to put on GitHub. Like I said, if it goes on GitHub, assume it's going on tomorrow's front page news. So don't put anything that you wouldn't be happy to see on tomorrow's front page news on GitHub.
Can you keep it private so that nobody will see it?
You can keep it private so that other users cannot access it. Microsoft can read it. Microsoft will read it. It is not GDPR or IRB compliant to do that. So you never put information that needs to be private on GitHub. You can stop other people from seeing it. I've never done that. I don't care if people see it. There's nothing here that's private. The only reason you would do that, in my opinion, is if you had intellectual property or you're developing code that is copyrighted or is like for commercial use. And in that case, you're probably not using GitHub. You're probably using an enterprise or an on-site stand-up of something similar. So I've never in my life seen a reason to make something private. A lot of people I work with do think that their ideas are going to get stolen, but we're not giving access to the data anyway, so the code's not going to run even if you have access to it. So I never found a reason to do that. It seems to make people happy, but I think it's silly and it's not truly private anyway. So I hope that answers the question. Yeah, Amy.
This might be a really rudimentary question, but my background is in qualitative research. And so my question is this only for code, or is there a case for using this for transcripts as well?
So if your transcripts are stored in plain text,
yeah,
meaning if they're dot text or dot markdown or something like that, you can absolutely use it to store transcripts, and it'll be very useful because it'll show you if you make changes, line by line, word by word changes. You probably don't want those on the public internet, right? I'm guessing,
unless if they're de-identified, but yeah, longer conversation
right.
about transparency and reproducibility. Yeah,
correct. You don't have to use GitHub. Like I said, Git can live entirely on your local machine, so it's useful anyway. If they're totally de-identified and you want them to be backed up on the internet or to be available through the internet, then absolutely. As long as you're using a plain text format, it will work. Sometimes, I wrote the book that I showed you, we wrote the whole thing in Git, so it works just fine. You sometimes have to modify your writing style a little to use plain text because you'll tend to want to break up sentences over lines so that it tracks them properly as opposed to writing one big block on a line, but it will work. And it'll work very well as long as it's just text in that file.
Okay, thank you.
Mm-hmm. So once we have something living on GitHub like this, we do what's called cloning it. Now, as you know, in the repository is the history of all the files through a series of snapshots, and we can make what's called clones of that. So if our gold edition is the one that's on the internet, which is usually the way that we treat that feature, everybody who works on the project can make a copy. And all the copies are just as good. They have the whole history of the project stored on it and show each other what they're up to. So when we copy that repository to our desktop computer, we're getting everything that has been done to all the files, all of those snapshots that have been stored in the repository, all of that work that's been encoded in human language with dates, timestamps, authors, and the reasons for the changes is copied over, and we'll be able to look at it. This is a good way to start a repository, and this is how I always start is what I just showed you, starting on GitHub, cloning it to my computer. Your computer will talk back and forth with the copy of the repository that is stored on GitHub. And when you do it for the first time, it'll look like this. You'll see that it's a very simple repository, obviously. It's just got a little note about what it is. And the local copy, the files that are living in the working directory on my computer, in my file system, look exactly, you can see my pointer, right? So I have here on the local copy, readme.md, the markdown file, and particularly the readme file, if you haven't used it before, which is a special file that GitHub will automatically display on the site when you're in that folder. So special name, special file. And it's identical contents between the copy that lives on GitHub and the copy that's living on my local machine. Sounds good, right? Next, I'm going to make some file. It's going to be, because I work in Stata, because I'm an old economist, it's going to be a .do file, and that's usually who I teach these things to. It's going to be something like my do file.do. I'm going to add it locally to this repository, the working directory for this repository. Here it is, my do-file.do. And even though we know that Git is watching what we do and that Git is communicating with the GitHub server, it's not going to do anything without your permission. So a part of learning to use Git is learning the workflow of, okay, I need to pop over to the manager and do something that isn't done in the course of my normal work. And here's why. When you go ahead and look at the local copy of the repository and the internet copy of the repository, now they're not the same. And you're going to say, Ben, the whole point of this is that we're supposed to have a backup. It's supposed to work. It's supposed to be semi-automatic in the background. Oh, look, it's not. You have to do these things yourself. And I'm about to show you why. And finally answer that question about why do we name the things. Git is watching. It tells you right here. This is how Git Kraken displays this status. Other clients will do it differently. You have a WIP, a work in progress. But it won't make that commit without you. It won't sync information to other servers or clients without your permission. And the reason why is because you have to give it the reason for those changes. You have to say, this is a meaningful change. This is the human reason why I've made that change. And I would like you to send it to my boss. You don't want a software that's sending stuff to your boss without your permission. Believe you me. There's lots of lawsuits about that around here on labor rights and stuff, but Git won't do that for you, so that's fantastic. What you do is use, yeah, did somebody say something? Yeah.
So the snapshot is not automatic, it depends on what you permit.
That's exactly right. So remember when I showed the history that is made automatically by Dropbox? It's terrible for a reason, right? Software and computers, no matter what people try and tell you about artificial intelligence, they're not intelligent. They will never understand human things. So Dropbox solves that problem by doing it every time it can, which is why it creates such a big old mess on the background. Git is much smarter because it knows that it is stupid and it knows that you are the smart one. So it waits for you to tell it when to do the thing. And those are really the only two options. Unless you invent a crazy intelligent machine, which you won't because machines can't be intelligent, this is the best way. You have to tell it what you are doing. You'll call it something like add this important file. So again, to come back to the grammar of the thing, you'll see in English that works both as a command and as a description, which is why we use that tense when we're writing those descriptions. We start with a capital letter. We don't end with punctuation. We just put the command in there almost as if we were telling the machine to do a thing. If the machine was intelligent, that's what you would wanted it to be done if you gave it that order. It's clever and it works. We commit those changes. And again, unlike Dropbox, to answer that question a second time in a different way, we let it know that we've not only changed one file, but that we've actually made progress in the project as a whole. So again, when we commit changes, we are snapshotting the entire state of the working directory. So whereas Dropbox is gonna, every time I make a file, take a snapshot of that file, Git is gonna wait until you say, okay, all the pieces are working together now in a way that I think is good, freeze it there, and then keep working. So again, machine has no idea. It has no way of knowing that you need to go and change another file now that you've saved this one. And we do that all the time because that's how our projects work. That's how humans organize. Machines organize like crazy. You've seen the Matrix or actually looked at the behind the scenes on a web page. The stuff's unintelligible. It makes no sense. It works, it's just not human language, and you can't read it because it's not human language. Once you've made a commit in this way, you're going to do what's called pushing. Here's a little button for push, and that's how it's done in this client. Those changes to the remote repository, so on GitHub. So again, this thing will not send information anywhere unless you tell it to. It takes a little getting used to, but it is the right way to do things. You basically, unless you're doing something really weird or sensitive, want to push essentially every time you make a commit, so that that work is backed up on the internet and is available to your boss and your collaborators. And then the other hand is pulling, where you get that information from the server that other people are doing to your computer. The only reason it's not automatic is because if it was constantly checking, it would use a lot of bandwidth and internet time, which some people have to pay for by the minute, and which, again, Git is not greedy. It is not going to do things without your permission. Lots of other software will. It will spend your entire, cell data plan, syncing when you're sitting in the middle of, a hospital in the desert, which I do a lot. And I don't want it to do that. So that's great. Once you push those changes, the local and remote are in sync. GitHub will always display the most recent commit on the main branch. You can change it around by changing branches, and we'll show that in a second. But like I told you, you might have a question now, because I told you there's only one thing in repositories, right? And that is, anybody can answer this one now.
The latest version? I don't know.
Not the latest version, but all the versions, right? All the versions are in the repository. And what are those versions called? Sorry, it's a pop quiz.
Commit.
Yes, they're called commits. And that's the only thing that sits in repositories, isn't it?
Yeah.
So what am I talking about when I'm talking about branches? Any guesses?
The commits at different stages. I don't know.
Something like that. So branches are hard. I mean, I'm gonna, talk about this thing. Commits make sense. Commits are something that you can visualize in your head, right? Yes, sorry, I don't have your name there. I just have your email address. What's your name there?
Ayebila.
Ayebila, nice to meet you. Go ahead.
Yeah, nice to meet you. So yeah, I want to talk about the branching.
Mm-hmm.
Yeah, so branch, you can make different, like a copy of your master repository. So you can make different copies of the master repository so that you don't mess up the master in case you want to play with stuff.
Yes, that's a pretty good start of what they're for, and I'll explain exactly how you do that. Again, we're going to use main, the terminology main going forward rather than master, since that's the new standard. But yes, you're going to make something like a copy, although it's not going to be a full copy. So a clone is a copy, and a branch is something slightly different, but it feels like that. So that's a great analogy. One thing I'm going to tell you right now, it's going to pop into your head in about 5 seconds. And I want you to just, as soon as it happens, banish it and say, no brain, I know you are trying to make this intelligent to me, but for once you are wrong. It is not like a folder. Nothing like a folder. You don't put commits in branches the way you put files in folders. It's going to feel like it. It's going to look a little bit like it, and you're going to be tempted to think of it that way. Stop that now. It is wrong, and it will disrupt the way that you think about how to use branches and stop you from using them the way that they're meant to be used. So not folders, all right? Git creates branches. Now, again, you mean that to me because I told you Git doesn't create anything but commits. And that's true. I told you I had a little asterisk. There's a little asterisk. Branches are what makes Git Git. Look, it'd be good enough on its own if it just did the history thing, right? That's already super useful. But it does something weird and different that no other software really does. And yes, it's called branches. This is how, to answer Amy's earlier question, different people can work on the same thing at the same time, but not really the same thing, which I'll explain later. And branches let you look at different versions of your files, including the ones in the past. Branching lets you move forward and backward in time, which is easy concept to understand. They also let you move horizontally in time, which is a harder thing to understand. Who likes time travel movies? Any favorite ones? Because you're gonna name the honey, like, okay, there's Looper, that one was stupid. Hot Tub Time Machine, that's very funny. Primer. Primer is a classic that's out there that a lot of people haven't seen, but is absolutely insane. Probably the closest to how real-time travel works, because as soon as you jump in the time machine, everything is absolutely screwed up, and it just gets weirder and weirder as you keep going. Watch Primer if you haven't, if you really want to not understand what you're looking at. It's something like this. So we're going to move horizontally in time. What branches do is they name current versions. A branch is nothing more than an access point to a commit. So it is extremely lightweight. It's almost nothing at all. But without a branch, you can't get to a commit. So you have all that lovely history. Somehow you're going to, at some point in the future, I'm going to show you how to make these simultaneous versions. And the time path, the history of your project is going to look something like this. You say, Ben, that's crazy. The history is branching off, which is why we call it branches. This isn't linear. This is not how the world works. And I say that's absolutely correct. That's why we're learning something new and difficult and building a new mental structure for it here today and going forward. Yes, we have a history that is not very much like the history that we live through in terms of linear time. It has, excuse me, alternate possibilities, although this gets a lot easier these days because people have spent a lot of time watching Marvel movies. Have we watched Marvel movies? What? Come on, guys.
Only Black Panther, anyone? That's the best.
Black Panther's, that's not even the one that has alternate timelines. We're talking about the mainstream stuff, the big, what was that? I don't know what they're called. I don't watch them. I'm just trying to get something here. Alternate timelines that are happening at the same time, different possibilities of the way the world could have shaped out. What does Doctor Strange say? I've lived through a million timelines and the Avengers succeed in just one of them, you know? And that's what research projects are like. So, so you can switch between these different possibilities for the way that your work could have gone, is going, might have gone. We don't have great vocabulary for alternate timelines because they're not real, but we can make them kind of real, and now we need to talk about it. So anyone can make an access point to any commit at any time. So you notice I'm not going to talk about, I'm going to immediately start doing it again, the way that Ayabila was talking about it, or the way that I was telling you not to think about it. We're going to start to think about branches as containing commits, the way that this diagram looks like it does. That's completely wrong in a fundamental way, but it is useful. So again, you can think about that. You might refer to something as the commits on this branch. That's confusing the structure of the timeline with what a branch itself is. And a branch, again, is just an access point to a specific commit in the history of the project, which is called the repository, which contains dates, timestamps, and snapshots. Got it? A branch will let you go into the past. If I make a branch pointing at this commit, I can see it. I can't do the live demo now, but I can later if you want. A branch pointing here will let you see this commit. A branch pointing here will let you see this commit. Oop. A branch pointing here will let you see this commit. And C is an interesting word. It puts the history, the state of the entire repository, the entire working directory at the time that that commit was made into your computer now here in the working directory. It's basically magic, and I'll show that to you during the Q&A demo session, which is coming up kind of soonish, so I should get through this in the next 10 minutes. Now, why are we doing this weird simultaneous multiple possible history thing? Again, those of you who use Dropbox or any other similar software have seen this happen on your computer. This is worse than the last one somehow. I didn't think it was possible, but this is worse. Why is this worse? Someone tell me why your day is over when you see this happen. Somebody's got to have been here. I can't be alone suffering on my little conflicted Dropbox. Because you're screwed. You have no idea what is in Guadalupe Bedoya's conflicted copy of this version. And then this has both problems going on at once because it's a very silly way of keeping track of our files, but it's what we do. What's the difference between PE changelog 16 March 2014 IKA, I don't know what that means, and PE changelog 18 March 2014 Guadalupe Bedoya's conflicted copy? I'm screwed. I'm spending the whole day figuring out what's different, resolving them back into the files that I actually want. And for some reason, you know, figuring out what date those things happened and making the proper version sitting here in my working directory. That's going to take me all day if this file is any reasonable size. And if I'm doing a difficult job, which I am, and I'm sure you all are, it's going to take all week. You are just done when you mess up like this and you crash into each other. So again, to answer Amy's earlier question, people can work on similar things at the same time. We can create alternate possibilities for the same thing at the same time, but we never, ever, 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 ever work on the same thing at the same time. And thankfully, once you start thinking about it, Git makes that very easy because we can make alternate possibilities for the same thing very cheaply. And each have our own even if we want to. And they won't run into each other until we're ready. So again, if you go on Dropbox and you do that history thing and you try and get in here and fix your mistakes or get those old things and you roll it back, Dropbox is what we call a syncing service. When you want to go back, everyone else has to go back too. Git doesn't work like that, right? It's distributed. Everyone has a full copy. Everyone can create their own access points and go to different timelines on their own without affecting everybody else's stuff. So you can see old things or new things without inflicting them on other people who are trying to do other things. Which again, in Dropbox, you can't work on the same file at the same time. Yes, go
ahead. So how does it group per? I don't know if you mentioned this before, but it keeps popping in my mind. How does it group per project? For instance, if I'm done with this project and I want to move to the next project, I have to create another GitHub or something. How do I group per project?
Yep. So we keep
For
projects.
instance, if I have 3-4 projects, different projects I'm working on, can I sync in the same GitHub?
Right. So we keep projects a lot more separate than we're probably used to. Even if I'm doing two different things with the same data set, I will create different repositories for each of them. The way I tend to work, again, because I'm academic, I will create one repository for each manuscript because that's the level at which my life is organized. For different type of projects, it'll be different type of organization. But that's what works for me. And again, it's because, that's a human concept. The computer has no idea what a manuscript is or why I'm spending my life writing them. But I will do one repository for each manuscript. So, you might do one for each report, you might do one for each, whatever you do. One for each piece of software is typically the way things are organized. If you're doing computer software development, and others work differently. It's a legendary rumor that Google has only one repository and that Microsoft has only one repository. Don't ask me. Windows presumably just has one repository, which I think is insane, but that's what they do and it works for them. So again, I can't give a prescriptive answer as to what you ought to do, but the answer is always make it make sense for the tasks that you have to do.
Thank you.
You're welcome. That makes sense. Talking about branches. This is what branches look like in GitKraken, and this is another reason why I really like GitKraken because it shows them to you in a very intuitive way. We're going to open up a repository. It's going to look something like this, where I've started that repository and added that do file. I'm going to create a branch, which has a very nice little drop-down menu where I can do it. You'll see it says create branch here. So like I said, a branch must point to a commit. So you have to create a branch pointing to a commit. It's always a commit that already exists. And people say, okay, this is silly. This doesn't add anything new. But as soon as you start doing, I did it from the initial commit. So we're actually going to create an alternate version history very quickly. So I created it pointing to the earlier commit. Now this shows two things at one time, so let's not confuse them. When that branch is checked out, so you can see we've checked out the develop branch in our using our Git client, GitKraken. We are now what we call on the develop branch. What does that do to your computer? It makes it look like it was when that commit was made. So where's that file gone? Where's that do file that I added to that folder gone? Well, it's not there because it wasn't in the working directory when that snapshot was taken. Weirdly, not weirdly, magically. Go back to, again, this should say main. I need to update these slides. Check out the main branch again. The main branch points to the commit where the do file is added. And when you check out the main branch again, you will magically see that file there in the working directory. So you're gonna be switching back and forth between the place you know, the file manager on computer, and a new place, the repository manager, the Git client, that controls where in the timeline your computer is showing things from. I know this is starting to get a bit weird, but that is what you're doing, and it's very, very cool and very, very useful. So we're going to go back now to what we call the develop branch. Yes, Abdul.
I was just wondering, so does it save this, or is it like one version, but once you point to a certain version, then it brings it up? Or so I don't know, is it saving multiple files, or it's one, but it shows at what stage it is? I can't understand it. Yeah.
Yep. I'm happy to demo that after this if you want to see it happen in real life. Like again, it looks like magic when you see it. It's always the same folder, but by changing the branch that you are on, which is the commit that your this thing is pointing to, it actually magically instantly changes what shows up in the folder, the one folder on your computer. Does that make sense? I'll show you after I finish the lecture, and then it'll make a little more sense. But it's absolutely magical the first time you see it. The fact that you can just because we're used to thinking of, like I said, linear time with ourselves at the very end of it, not knowing what comes next. But Git lets us move forward, backwards, sideways through time. I'm going to make a Marvel themed version of this presentation. It'll be very funny. It'll probably work really well too. So we're going to check out this develop branch again. And again, the way I've done it here, the develop branch points to a commit that does not have this additional do file, right? So what are we going to see? We're going to see the version of the working directory that does not have that additional do file. Let's add a different file to it. Another do file .do, because I'm very clever and creative here. Same thing we did before. We're going to stage and commit these changes. You're going to see it's going to start to draw that timeline for you, and it's now getting weird because we're branching the timeline to alternate possibilities of what could have happened in this project, right? Stage them and commit them. It's going to fill in that little bubble. The develop branch now points to this commit. The main branch now points to this commit. And can anyone see the problem here? We want both of those files, don't we? And so this is how it'll begin to happen when you're collaborating. I'll be working on one branch, you'll be working on another. We're creating our own separate, alternate, disconnected histories of what we want in our project. How, and we're going to do this with a fun analogy, little Marvel thing. How do we get both those files in the repository at the same time? We need to create a commit. That's the only thing we can create that has both of those events in its history. We need to merge the timelines. And we can do that. That is the last thing that we can do, and is how we work on Git and GitHub together. GitHub is the place to do this because we are talking about different people, different histories contributing to a single current version of past, where even though we were briefly not on the same timeline, we are now going to create a future where we can look back and see both of those things, which means we'll have both of the files. Again, sounds like I'm talking crazy talk from another universe. I kind of am, but this is really the fun part, and this is how things get done. GitHub manages this process very sensibly. We're going to go ahead and push that branch to GitHub so that our friends, bosses, enemies can see it. We can click around, it'll show up on other people's computers. Now you can see here in this little side window that the GitHub has the develop branch and the main branch. We're going to go to GitHub. We never merge on our own computer because GitHub does it much better. This is what GitHub is good for and why we use it. We're going to open a pull request. I hate the word pull request. I think it should be called a merge request because we already have a verb called pull and it does something entirely different. It's called a pull request because that's what GitHub calls it. It should be called a merge request. This is the way we do it. Going to skip over all the technical details, create the pull request, merge the pull request. Now go back to your computer and hey, ta-da, pull. This is why it's a stupid name. We're now pulling the main branch back down. And look, what have we done with that pull request, with that merge function on github.com is create a commit. All we can do is create commits, so we're going to stick to it. We're going to create a commit that has in its history both of these divergent timelines. That's what a merge does. It creates a single commit that can see two histories. And when you think about it from that perspective, it's not surprising that once you check out the main branch, which points to a commit that has both of those files in its history, that when you go back to your working directory on your computer, both of the files are in it. So that's the magic. I only ran 5 minutes over, which is not bad because we started about 5 minutes after time. So I'm still doing very well on this. I hope no one's brain hurts too much, but we have about 20 minutes for whatever you would like to see. I can do some stuff live. I can just answer questions for a while. Whatever is important to you now, I am happy to talk about. So I'm going to go ahead and open it up. Yeah, let's do that. Anybody, even if you just want to talk about Marvel movies. I don't have much to say because I haven't seen most of them, but the timeline thing is actually very useful now.
I was just wondering, so if you don't have internet connection, what happens? Does it do it when you are online or it doesn't update?
So Git, again, I'll go back to the beginning here because that feels like it was a long time ago, but it might have been simultaneous. Git is running on your computer, just like an email. You can compose emails when you don't have the internet, right? It never connects to github.com until you tell it to. You have to say, push my changes to github.com, just like when you click send the email. So you could write emails when you don't have internet connection and send them when you get back online, right? And GitHub works exactly the same way. You have Git running on your desktop. You can make commits there on your computer. You can create branches, make alternate versions, do all your regular work, and not sync it until you get reconnected to the internet. That works just fine. It's never trying to communicate automatically, so it's not going to give you errors or crashes or anything weird at all if you are working offline. Yeah.
Is there anything you don't like or would caveat about using GitHub and Git?
Yes, that's a great question. It comes back to your transcripts question. Git will not work for Microsoft Office files. It only works for code and plain text files. So it will not work with your PowerPoints. It will not work with Word documents. And this is because it only tracks text. Those files, most files that are like Microsoft Office files, Adobe files, stuff like that, is stored in what's called binary format. And what that means is that what you look at is just like this, translated from a computer language into a human representation. There's no structured way to save in Office a Word document. Think of all the things that are translated for you to see, whether something is bold, whether something's indented, how big the font is, what font it's in, if there's a header or a footer, if there's colors, if there's highlights, if there's smart art, if there's all this stuff that you put in Word documents, that's very unstructured. And so in order to save that as a file behind the scenes, Microsoft Word or Microsoft Office translates it into a super compressed computer language, which you can look at. If you go ahead and open, and you might have done this accidentally once or twice in your life, opened a picture or a Microsoft Office file in a text editor, it looks like nonsense. And yes, GitHub can store that, but because it's because of the way the compression works, even changing one sentence in a Microsoft Office document will change the entire structure of the compressed binary. So the tracking and storing that GitHub does kind of gets wasted because it can't store small changes the way that it can with plain text documents. So there are new technologies coming out and protocols that will let you at least store some of these documents efficiently. But that's not what GitHub is for. And so usually when I'm working with a project in Git or GitHub, all of the code will sit in my Git working directory in that repository. But in fact, it'll have lines of code in it that say, open this data set. It's not good for a lot of kinds of data either for similar reasons. Pull this data set in from Box, which to answer another question that hasn't been asked yet, meets our university security standards for storing identified confidential information. Process it in Stata or whatever we're using, and put the results back in Box. So those things actually never hit the Git repository, the data or the outputs. Literally just the code is sitting here. And honestly, that's all we need because the code is the recipe for the things we're trying to create. As long as the data, the original information that we're operating on is stored somewhere securely, that doesn't change very much. So we don't need these features. And we do need it to be handled in compliance with our IRB protocols and our legal regulations, which our enterprise version of Box does. So the code knows to look for it there, operate it on it locally, and save my results, again, back in the confidential protected location without ever exposing them to the Git algorithm or to the public internet. And it sounds a little complicated, but it's actually very, very easy to set up once you do it.
No, that was helpful because I was curious if it would replace a box, but it sounds like it just calls for material stored in there, uses it, and then puts it back or is told where to put it. Okay.
Yep, absolutely. And it can do that with any kind of file storage. So if you're doing big data stuff and you have things living in an Amazon S3 bucket or whatever, it can just as easily, you're writing whatever code you want. So it doesn't change anything about the way your code operates, right? It just tracks your code and sometimes your outputs depending on what you want to do with it, and lets you collaborate easily. So if you write, for example, and I don't personally, I would do this. If you write in LaTeX using something like Text Studio, which I don't, I use Overleaf for stuff because I find that that's a more intuitive way to access that. But lots of people do write in LaTeX on their desktops. It tracks that, lets you manage, contributions and collaborations through files like that because tech.tech is a plain text format, right? It stores all of your work in a structured way. You have to code the formatting and the layout, but you can read it. When you look at that file, you're actually looking at the file contents, the real file contents, unlike with a Microsoft Office document or something, if that makes sense now. So it'll work for stuff like that. And people will, again, do that, in the one repository per manuscript mindset. Do you guys want to see it work? All right, let's see if I can do that. I got 10 minutes, so I might as well show you the magic. Am I sharing anything now? No, right? Good. Helpers, do not disturb so you don't see how messed up my life is. Let me share my desktop. All right, you can see this now?
Yeah.
All right. Okay, so here is a project I'm working on called Covet India. Here, if I go to my GitHub folder, I have all the stuff that I'm working on right now. And then there's more stuff online. The nice part is I can do this. I'm going to close it in here. So this is a really important project that's due next week. And it's good for our grant deliverable. You know what I'm going to do? I'm going to delete it. It's fun, right? So this is why I use it even when I'm not doing anything. Here it is online. It's got all my stuff. I can go ahead and grab that URL, pop into my repository manager, clone the Covet India repo, clone the repo. And hey, look, it's back. There's all my stuff. I'm not about to get fired from my job. So that's nice.
It's wild. My heart stopped.
It's good. You can just start doing like the most dangerous stuff and give people absolute panic attacks. So here's what I'm talking about when I'm talking about going back. I'm going to go ahead and create a branch here at the initial commit called go back. My stuff's gone again because I'm now looking at a version of this repository where I didn't do any of the work yet. My boss is not happy. This was a week ago. So I'm looking at what it looked like a week ago. I can just as easily change the branch back to main. As I said, we use main is the terminology now. And hey, there's my stuff again, because I'm now looking at a version that I saved 4 days ago. I can kill this branch. The only thing you can't do is kill a branch that's at the top. Don't do that because then you won't be able to access it. That is actually important. So don't delete all the branches. You need at least one and you want them on. So if I delete main, I can screw this up royally. But again, if I screw it up royally, this is going to look really bad. See, it won't let me. Even if I did that, if you mess things up, delete the repository, go back and get it from the internet, which is why we commit often and why we synchronize with the remote often, because the stuff is always there. I probably deleted something important. I certainly deleted all my data. But thankfully, when I open up my code editor, here it comes. Slowly. Doesn't want to cooperate today. Yes, when I open up my code editor, really doesn't want to cooperate today. Come on, show me my files. There we go. I have a file in here called makedata.do, which starts by grabbing my data from box, and putting it in the place that I need to operate on it. So if I just go ahead and run make, I have to run the run file. So I run the run file, run makedata.do. Hey, look, there's my data. And so you can see the data is being put in this data folder, but this editor is showing it grayed out. That's because we're using what's called a git ignore file. This tells it, this is some code stuff, but it's a standard template. It tells it to not synchronize the types of files that Git doesn't work well with. So it's not following my DTA files. And by that method, again, it's also not exposing them to the public internet when they're not. Yeah, this has people's names in it, so I can't even show you that on Zoom. So it's not putting me at any risk of, ethical or IRB violations or anything. You can delete stuff from the history. Generally, you don't want to because, again, that's your work. But you can. It's always better to not put yourself in a position where you have synchronized something that is sensitive, because cleaning it up is difficult and dangerous to your other work, but it is possible. So there's always a way out of problems, but it's much better to be safe going forward. And honestly, it's not that hard. If one of our later sessions is how to do this stuff practically, but if you look at what I'm doing, it's not very complicated. If you work in Stata, this will look very familiar to you. All this does is load the data that I've copied into here, but is not being tracked, and creates figures and puts them here. It's really simple code. I can show you the figures, although that's now going in a different direction. Making pretty pictures in Stata, which is something I enjoy doing. So again, we have 10 more minutes. Anything else you want to see? Should I make a new commit and then delete it or something? Yeah, let's do that. So I'm just going to go ahead and, again, you can see that I have no fear of just like absolutely going ahead and typing random stuff in my like actual work. This is something that could get me fired. JK, blah, 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 blah. Here's some code. It's not going to work. Save the file, pop over here. Shows me my work in progress, like I showed on some slides. If I click on that change, you can see I'm now selected it. It actually shows me what I've changed. If I click on it, it shows me what my changes are. I can keep the other stuff, or I can say, yeah, let's take this, 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 and this. So it's adding it to the main copy that's on my branch. I'm not going to keep the thing that could get me fired. I'm actually going to go ahead and make good, I can't spell, decisions, make good decisions. You see that there is still a work in progress. Oh, it's the thing that could have got me fired. I'm actually going to go ahead and discard that. So it knows what I've changed. I can just go ahead and roll that back without any problems. Look what's here in the actual file, just the things that I wanted, because it is controlling the version of the files that are on my computer. Actually, I think that's a terrible idea. I want to roll that back. Let me, I can do something like this called reverting a commit, which undoes what I just did. Oops, I didn't want to do that. Thankfully, there's an undo button. Stage, discard. Don't know what I'm doing, but if I screwed up, I can always go back and get my old problems back. I can revert this commit. I'm going to revert, make good decisions. You'll see that I can always go and look at exactly what the changes are. It's deleting those things that I added because those weren't actually good decisions. And you see, even though I've done this for real here as part of the demo, I'm going to leave it on the timeline because I did it and I undid it, and that's the history of this repository now. I'm not going to show you how to delete commits because you shouldn't be doing that, and it's really dangerous. Instead, I'm going to push that to my backup online and show my boss that I'm making good decisions, and then for some reason undoing them. And look, it looks in the file just like it did before I started because I went back. Yes, Abdul Rashid.
So is there any best practice how often you should create commits? Is it like weekly, daily, or just after some topics?
So the way I like to think of it, and I cover this more in my workflow session, which again, I'd be happy to teach if I'm ever invited back, is I make a commit when I finish a task. And that could mean a lot of different things. So here you can see sometimes it's a couple times a day. So I made some final figures, I made some updates, and then I finished the zero draft by adding tables or something. Here I made the main results, then I made the key figures, then I cleaned them up by putting like the formatting and stuff on them. So it's human tasks. It's the things that are on my little checklist. And when you check them off, the nice thing is that because we use, well, I'm not using the grammar very well here. Am I using it better over here? Sure. Bootstrap standard errors for comparison, right? It's a command and a description. Update caseloads. Some of these, sometimes I'm good at this and sometimes I'm not. You know, rerun the optimizer, clean up junk, get the names right. These are all tasks that are the things that I do throughout the day, and probably very similar to the things that you do throughout the day. So sometimes here is something that's, yeah, every 45 minutes, it looks like I get something done, which, you know, could be better, could be worse. And sometimes it's every couple of days. So here's before Christmas and here's after New Year's, right? Because I got COVID again and sat on my couch for 2 weeks sleeping, which was not awesome. So try and be safe out there.
I like doing the Lord's work. I don't know what was the inspiration for that.
That's probably something really bad. I use that as something very dumb. What did I do? But look, I can just go and look. Oh yeah, it's all formatting and adding new stuff. This is what I needed to get and I made a picture. Yes, I made a nice picture about a bunch of countries in sub-Saharan Africa. So this apparently was the Lord's work that day, or I was really tired. Yeah, 8:51 p.m. So I must have been, sick of working. Actually, even for me. So yeah, you can say I added, and you can. This is the great thing. You can go back and see exactly what I did. Now you know what the Lord's work is. It's properly weighting health facilities in Tanzania. Good for me. So obviously these are not things that I share with other people. I'll show you one that I share with other people because that's probably better. So here's IE Toolkit, which is an actually collaborative project. The other ones are just, you know, my things. So much more proper stuff. So here you can see Chris is working on stuff. Chris is working on a lot of stuff. He needs to stop working so much. Luisa is doing a little bit of work, and stuff merges together. So here's a version that's a release on the main branch. Here's the IE do rep command that I was working on. So you might notice in these alternate histories, I'm not going to call them branches because again, that's starting to confuse. We each work on one, right? And then we merge them together when we want to combine stuff that we've collaborated on. So again, that's one of the early questions that Amy had was, how do people work on the same thing? And the answer is, well, we work on the same thing by creating alternate possibilities, alternate timelines for that thing, and making a commit that looks back on both of our work in its history. And that's how it works. And this goes on for years. It's a little confusing, but then everything gets cleaned up and we make releases, we publish stuff, there's a nice release, and then everything branches back out as we start to do more different work. Then everything comes back together in these releases. You can see where you can see it in the history, right? When you read the graph, the history graph, and then everything branches back out again. People do different things. Then we make a release, everything branches back out again. So you can see how it is structured around basically creating a single version, then making all these possible changes to it, and then bringing them back together into something that we can publish, right? There's another release right there. So pretty cool. 4 more minutes, something in the chat. Is there a way of automating the commit process? Absolutely not, and we should do that, Francis. Excellent question, but no, and for the reason that I said before, machines will never be intelligent. I don't want to say humans will always be intelligent because I'm sure you've met some type of humans in your life, but we are the intelligent ones, and what Git does is let us use our intelligence for the things that it's for and not for doing stupid housekeeping. Machines are great at housekeeping. They got a robot vacuum cleaner. I'm smart. Why am I spending time vacuuming my own floors? A machine can do that. That's not hard. It doesn't take any creativity, but machine can't cook. I can cook, right? Yeah. You tell the machine tell the machine make scrambled eggs. It's gonna take an egg. Oh, you didn't tell it to turn the heat on. You didn't tell it to flip it. You didn't tell it to put the oil, right? It scrambled an egg, right? That's not a process that makes sense to a machine. And actually writing down step by step how to make a scrambled egg will take you more time than you realize. We always do that with new people. Is we do the exercise called how to make a peanut butter jelly sandwich. And we get the new hires and we say, okay, just take a piece of paper and write down how to make a peanut butter jelly sandwich. And then what we do is we take the paper and we follow the instructions exactly as it's written. And what we give back to them is usually not the peanut butter jelly sandwich they had in mind. Try it sometime. Write it down and follow step by step, and you will be surprised at how long it takes to describe how to make a peanut butter jelly sandwich. And that's a simple thing. Get the bread out and put the jelly on it. Okay, the bread's out of the fridge. I'm putting jelly on the package. Take the bread out of the package. Okay, I've taken the whole loaf. No, take one slice of bread out of the package. Put it on its side. Put it on this side. Unscrew the lid. I did put the jelly on the bread. No, unscrew the lid to the jelly. Put the knife in the jelly. Like, when you really start getting into what it takes to describe to a machine how to do it, you will understand also why there will never be self-driving cars. It's not going to happen. All right, thank you guys all very much for coming. I hope this was helpful. Amy, if you haven't circulated the slides already, please do go ahead and send those out. I know you do that after the sessions. My contact information is on there. Don't be afraid to reach out and say hi. I'm always happy to talk. I have lots of information on these things on Diamond Linux website. Read my book, it's free on the internet. development, research, and practice. You can get it from my website, which I think is also linked for my presentation. All our stuff is there, and it's really useful, and we wrote it for a reason. Go to DimeWiki, read our stuff. It's public information because we want to help people. Thanks again so much for coming. I hope this is helpful, and have a wonderful new year and the rest of your week.
Thank you, Ben.
Thanks.
That was wonderful. And I'll see you all on Tuesday for our next session. And it's on survey design and interview protocols with Jamie McCaslin. After this, I'll follow up with a recording of the slides and the slides themselves. So thank you all so much for your engagement, and I'll see you soon. Thanks, Ben.
Thank you.